Woo, we're live. All right. Algebra 2, lesson 5-1, zeros of polynomials. This is the first of 4 lessons in this very, very short unit. Today's date is Thursday, November 12th, 2020. It goes lesson, test, and we are done. Objective, Gunner.
Find the x-intercepts of a polynomial.
That's it. That one thing, and it has 2 homework assignments associated with it. Here we go. These 4 things are basically synonymous. They mean the same thing in a slightly different form. So get your head wrapped around these 4 things. They're basically the same. So functions. And then who are taking notes? I'm watching people writing down. Okay. Functions have linear pairs, factors. I'm not 100%. I'm going to say functions have zeros. So zeros is the word that I'm going to use when I'm referring just to a general function. If I'm talking about some sort of curve, that is a function that has zeros. Hey, lo and behold, that's the word of our title, right? Graphs have x-intercepts. Equations have solutions. Solve this equation, right? If you solve it, you have found the solution. I can't spell solution. And expressions have roots. That's right. Roots go here, not there. That was right. Okay. So if I have an expression, I can factor it and I can find its roots. If I have a function, I'm looking for zeros. All of these 4 words are basically saying the same thing, but in a different context. The context is functions, graphs, equations, and expressions. Again, expressions look like equations, but there's no equal to sign. Graphs are obviously a graph. It's pretty easy to distinguish it. This is an actual equation that's just given to you. Let's try this. So when we're finding x-intercepts, you always first want to factor everything. And you guys are now master factorers because that was unit 3. That was 2 units ago. So first step, you always will factor as much as possible. I'll just say factor. Next, you are going to what? Set the function equal to 0, exactly, because you're turning your function into an equation so that you can find the solution. And then finally, you're going to use the zero product property to get the solution to solve. Over and over and over, these 3 steps you will do. All right, so let me talk about the zero product property. I talk about it in almost every single class, especially Algebra 1 and Algebra 2. If A times B is equal to 0, that's all you know. I don't know what A is. I know it's some number. B is some number. But if A times B is equal to 0, what do you know about A? What do you know about B? Is that a hand? No? Kind of a hand. Josie. Say again? They're equal to 0. Yeah. In essence, they're equal to 0. Is there a little bit more like we can be a little bit more specific about what's happening? Charles?
One or both of the variables are 0.
Yeah, it could be one or it could be both. But in general, they're 0. So to plan for the fact that they both could be 0, as Josie said, we're just going to set both of them equal to 0. A could be 0, B equals 0. So whenever you have 2 things multiplied by each other equal 0, go ahead and say, hey, one of them, A, could be 0, or B could be 0. If those 2 are possible, then that is an answer. Oops, forgot to say 0. This always boils down into, or I guess expands into 2 different equations every single time. So let me switch what I just said. Instead of A and B, A is now going to be 2x plus 6. B is going to be x minus 3. I have a quantity times another quantity, and that is set equal to 0, which means you have 2 equations. Using the zero product property, what are those 2 equations? What?
2x plus 6 is equal to 0, and x minus 3 is equal to 0.
There it is. 2x plus 6 is equal to 0, which is the equivalent of A is equal to 0. And then you have a second equation, x minus 3 is equal to 0. Both of these equations, just like in Algebra 1, we would solve by isolating for the variable. For x, you get x is equal to -3, x is equal to positive 3, done. But you do now have to do twice the amount of work because you have 2 equations. Okay, so we have the zero product property. We understand the general procedure. Let's try it. I want you guys to plot the x-intercepts of this polynomial. Hey, I'm nice. I already factored it for you. I did step 1. You're welcome. I'm being nice. I will eventually be mean. Don't worry. X minus 3 times 2x plus 7, x plus 1. I did step 1. Do you guys remember step 2? Wyatt stated step 2, so I'm not going to call on him. He knows it. Jade? Set it equal to 0. So I'm going to go over here, be lazy, just say set equal to 0. And then step 3, remember step 3? Andres?
Would you set all of them to 0? Like
Yeah.
X minus 3 is equal to 0, 2x plus 7 equals 0?
Yeah, each individual one set equal to 0, and that's using the zero product property. So here we go. Andres' first equation is going to be x minus 3 is equal to 0. Andres' second equation is going to be 2x plus 7 is equal to 0. And Andres' third equation is going to be x plus 1 is equal to 0. Let's do rapid fire. Solve each of these equations. Charles, do the first one. X is equal to positive 3. Next one. Jade. X is equal to negative 7 halves. Perfect. And fractions I love, but to make sure that all of us understand, what is the decimal approximation of 7 halves? Jade? It is negative 3.5. Either one of these is fine. If you know that negative 7 halves is directly in between negative 3 and negative 4, then that's awesome. If not, you have this decimal to help you out. And finally, third one. What? X is equal to negative 1. All right, these are solutions now that we have an equation. You can also say that these numbers are, using our vocab up here, these are the zeros of our function. Or they're the solutions to the equation that we generated. See how I'm using our vocab? But we want x-intercepts. The question asks, what are those x-intercepts? And notice the similarities between all of the examples down here. X minus 3, x minus 5, x minus 3, x minus 5, x minus 3, x minus 5, but positive 3 and positive 5. Why did it switch signs from a negative to a positive? It's because of the zero product property. I had x minus 3 and then I got x plus 3. So I go to the x coordinate 3 on the x-axis, and that is an x-intercept. I come over here to that 3. That is an x-intercept. I graph it. That was my blue point right here. I do my orange point, negative 3.5 on the x-axis, and I go do negative 1. Done. The end. Those are the x-intercepts. Woo. All right, let's try another one. I'm asking it in a different form now. A polynomial P has zeros when x is equal to 0, x is equal to 2, and x is equal to 3/5. What could be an equation for that original P polynomial? You're looking through A, B, C, and D. Which of these match our zeros? So don't raise your hand yet. I'm going to make everyone do 1, 2, 3, or 4. Get ready to vote. Everyone is voting. If you haven't figured it out in time, you're just going to do a hand. A fist up in the air. Zeros at 0, 2, and 3/5. A positive 3/5. On your marks, get set, vote. Interesting. 1, 2s, and 3s, but no one said a 4. He said 5. Oh, okay. It's E. All right, let's do this. Okay, so in order for me to have an x or a 0 when x is equal to 0, that means x needs to be one of the factors. X is a factor in B and C, so I can eliminate A and D. Again, using the zero product property to explain myself a little bit better. Using the zero product property, for example, let's pretend that we're solving for B. I would set all 3 of these equal to 0, so I'd have 3 equations from that one polynomial. I would say x is equal to 0, x is equal to, x, what am I saying here? X minus 2 is equal to 0, and 5x plus 3 is equal to 0. Notice that I can only have x equal to 0 if I just had a normal x to begin with. It's only between B and C. Notice that both B and C have x minus 2 as a factor, so that's not going to be the distinguishing factor between the two. The distinguishing factor is one of them is a 5x plus 3, the other one is 5x minus 3. So how do we get a positive 3/5? Well, let's try solving this one, right? If we solve this 5x plus 3, I would subtract 3 on both sides. I'd have a minus 3 on the right-hand side. Divide by the 5. I'd still have a minus 3/5. That's not positive 3/5. It's not B, it was C. Everyone that gave me a 3, pat on the back, you got it.
So when it gives you that, I thought it was like, good job on it. Those are all like possibilities for what X is. Like, so I thought like for A, you can put Q as multiple and they would be equal to 0.
That's exactly what it means. Yeah, so if you plug in any of these 3 numbers into each of these x's, it should be 0. For example, let's plug in 2. If I plug in 2 to here and to here, this is going to be 0 times something. 0 times anything is 0, which means it is a literal 0. But you should be able to have this work for every number. If I plug in 0, for example, to letter A, 0 minus 2 is -2. 0 minus 3 is -3. That would be a positive 6. That's not a 0.
Oh.
Every single one of these 3 options should be able to be plugged in for every single x, and it should work. Not 0 and then 2 and then the 3/5, but 0, 0, 0. Does that work? 2, 2, 2. Does that work? 3/5, 3/5, 3/5. Does that work?
Oh.
C is the only one where every single one of those options gives you 0. Literally, it is a 0. That's a good distinction to make. Thank you, Charles. We got smarter for your question. All right, any questions before I move on to example number 3? All right, our final question for the day. Plot the x-intercepts of the unfactored form. 4x to the power of 3 plus 10x squared minus 4x minus 10. There are 4 terms. Oh my gosh. Are those answers already? Are you have the next step?
I think I know what we're supposed to do.
If I had paper, I know.
Okay, grab paper. Everyone's gonna have to do this anyway. Grab some paper. I'll let you guys try this on your own. What happens when you have 4 of these terms? I'll give you guys 30 seconds just in case people have no idea, and then I can give a hint. So my hint for everyone is your first step is always, always, always factor out the GCF. The GCF of 4x cubed, 10x squared, 4x, and 10 is 2. Factor out 2 first. That should have been your first step. From there, you'll still have 4 terms. You're going to do factor by grouping. Factor by grouping, again, if you don't remember what that is, it means you have a line in between the 10x squared and the negative 4x. I have 2, well, I guess it would be 2x cubed and 5x squared, right? Because I factored out a 2. You still have that line, and then you factor out the GCF of each of those 2 pieces. I'll do this in about a minute. I want to let you guys have some more time to work. All right, so factoring out 2, and again, you don't have to factor out 2 as your first step. If you just do it, then you can't forget about it, which is why I always have you do it first. If you factor out a 2, by the way, we're supposed to set that equal to 0 for our first step, I guess. When I'm factoring this thing, I'm going to set this equal to 2 times the quantity of 2x cubed plus 5x squared minus 2x minus 5, and that's still set equal to 0. How do I factor these 4 terms, this polynomial, this quadnomial, I guess? Andres?
So the factor by grouping,
Yep, how do I do that?
you put a line in between those 2 terms, and then you find the GCF for the left side.
Yep.
Which is x squared.
Yep, so I have that 2 is still being factored out, and now I have x squared being factored out, and what's left over?
It's going to be 2x squared plus 5.
Like that?
Yeah.
A little mistake, see if you can find it.
Good job on Trace, but it wouldn't be 2x squared, it'd just be 2x because x cubed minus x squared.
Okay, I didn't see. Yeah.
So it'd be still b plus 5. You want to keep going on Trace now that?
I think you guys kind of solved together. I'll give the next step to someone else.
Thank you.
Good job, Wyatt. Second step, Charles.
You factor out a negative 1
What do you have left over? 2x plus 5. And that's still being set equal to 0. So I can say that's still set equal to 0. And then my final step for factor by grouping. We'll give it a what?
So for your final factor by group, you keep the 2 out front. You got x squared minus 1 times 2x plus 5. And that's your final factor by grouping, but you're not done yet. You're just find the x intercepts.
Exactly, yeah. I don't actually need these square brackets anymore since everything is just being multiplied to begin with. So let me get rid of that. So this is our final factored form. Question, Andres?
Yeah, I just have a question. How did you get the -1 when you factor to the right side?
Someone aside from Charles.
Oh wait.
Who can answer that?
Wait. Never mind.
You answer your own question out loud for everyone else that had the same question.
So there is no GCF, so it's just 1.
Just one, but in order to match this 2x plus 5, I need to factor out
The negative.
Thank you. Yeah, we have to have the same group. 2x plus 5 is the same group as 2x plus 5. All right. So now what do I do? Oh, actually, we're not done factoring, are we? We're not done factoring. Why? I need to give it to someone new, but it is a harder question. I'm not going to force anyone new to do it. Sergio, do you know how to do this one?
I think I'm about it, but I want to.
Okay. Jose? Not quite. I can still factor a little bit further. This x squared minus 1 I can factor further. It is indeed x plus 1, x minus 1. Does anyone remember what that's called? What?
Difference of squares.
Difference of squares, yeah. 2x plus 1, x minus 1, 2x plus 5. And that is still set equal to 0. You know the next step?
Yeah, but I was just gonna point out that you can't simplify the x squared minus 1, but you can solve for x still in that form.
And you still get the right answer as long as you do plus or minus with the square root. Exactly. Yep. All right. Now I have 4 things being multiplied together. I have a 2, I have an x plus 1, an x minus 1, and a 2x plus 5. Set each of those to 0. And we'll get 4 equations, although one of them is kind of silly, but you can still set it equal to 0. My first equation, 2 is equal to 0, which can never, ever happen. So that doesn't generate any x-intercepts. So I'll just do it. Nope. Next one, x plus 1 is equal to 0. Next equation, x minus 1 is equal to 0. And final equation, 2x plus 5 is set equal to 0. Rapid fire, solve. We'll give Josie one of them. Solve any of these, Josie. Do you want to do x plus 1 is equal to 0? You want to do the green, black, red? Okay, x is equal to? Careful, you're going to subtract 1 on both sides. Zero minus 1. Negative 1. Close. Negative 1. Who else? Sergio, you do one of these. Plus 1, yep, positive 1. And Gunnar, do the last one.
-5/2.
-5/2. Perfect. And I'm totally cool with fractions, but to make sure that we all know where this lives, Gunnar, what is the decimal form of this? It's going to be negative something, right? Two and a half. There it is. 2.5. There it is. We have all 3 of our x-intercepts. We just need to graph them. Our first one is at -1 on the x-intercept because it's an x-intercept. It's on the x-axis. X is equal to 1. There's our black intercept. And our red intercept is -2.5. There it is. And we're done. Woo!
Can I quintuple or nothing this?
Quintuple, are you sure?
Quintuple,
So 50 push-ups or nothing? because quintuple 0 is still 0. So, I mean, your reward, you're just maximizing your consequence there.
Unless it makes sense.
Fist of 5 for our objective. How well can you find x-intercepts of a polynomial? 5. I think that's a 5, a 4, a 5, a 4, a 5, a 4. Josie's at a 4. Susie's at a 4. 5. All right. Thank you, guys.
I'm gonna start with